So, you have decided to adopt a microservices architecture? That's great. Now, let's talk about microservices. Microservices are a popular architecture that solves the drawbacks of legacy applications. Now, microservices are like building a big Lego structure by using many small Lego pieces. Each small piece does its own special job, and when you put them together, they make a powerful and flexible creation. Similarly, in software, microservices are small, specialized parts of an application that work together to create a larger and more adaptable system. So here is the architecture of a typical microservices application. Here the client is accessing the microservice as per need, and microservices are performing their specific task. For example, this microservice needs some data from this microservice to process the request. So to communicate with one another, they make use of inter-service communication on network level. They use communication protocol like HTTP, gRPC, or message brokers like AMQP protocol. They communicate synchronously or asynchronously over the network. So we cover communication mechanism in microservices in our upcoming video. And if you haven't watched monolithic versus microservices video till now, please watch that video by clicking on the I button. You will get more clarification by that video. So here is an example of an e-commerce application. There are three microservices here, and each one is responsible for a specific task. Here is payment processing microservice, add to cart, and user login. In microservice architecture, different teams can work separately and independently on different microservices. They can build new functions or add new functionality to the microservices without affecting other teams or functions. And even teams can use different programming languages and deploy their different microservices on different infrastructure. But for the sake of cost reduction and low operational complexities, most of the organizations limit their teams to choose a particular programming language or a particular infrastructure. So here it is a real-time complex microservices architecture. Here each microservice is connecting to the another to process request and complete its execution. So in this architecture, for example, if one of the microservice instance fails in production, it could generate errors within some other microservices also. And due to this distributed nature, it could be very difficult to identify the root cause and fix it. So to solve the issues of microservices, new tools were introduced. Some of the popular tools include containerization. By containerization, we mean it helps you to deploy microservices in a lightweight, self-contained runtime such as Docker container and container orchestration. It is a way to manage and coordinate the deployment, scaling, and operation of multiple containers within a complex application. So it is like conducting an orchestra where you are in charge of making sure all the instruments, which are here containers in our application, play together in harmony and adjusting their numbers, monitoring their performance. Example Kubernetes. And the other one is pipeline automation. It refers to the process of setting up and managing a series of connected steps in a systematic and automated way. So, automation involves using tools and scripts to handle these steps automatically, reducing manual effort and potential errors. Example Jenkins. So, asynchronous messaging. It is a communication method where different software components or systems can send and receive messages without needing to wait for an immediate response. Example RabbitMQ. And some performance monitoring tools like Grafana. So these are some popular tools which helps you to manage microservices in a more convenient way. So that's it for today's video.